Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which helps us in finding the sum of all the numbers that are formed from root to leaf paths. First, let us take an example. In this example, there are 4 leaves and hence 4 root to leaf paths. The first path is from root node 6 to 2. The second one is from node 6 to node 7. The third one is from node 6 to node 4. And the last one is from node 6 to node 4 in the right subtree. As you can see, we create a number from the path and add the number to give the final result. Now, let us have a look at the algorithm which will assist us in finding this. Let us also have a sample tree to test our algorithm. We begin with the first step and pass the root node which is 6 along with 0 in int val. Since root is not null, we update val. So, val will now be equal to val into 10 plus 6. So, val will be equal to 6. We check if current node is a leaf node or not. Since 6 has both left and right child, it is not a leaf node. So, we recursively call tree path sum util function for left and right subtree using a call stack. First, we pass the left child of root node, so 3 will be passed. Now, root will point to 3. Since root is not null, we update val. So, val will now be equal to 6 into 10 plus 3, which is equal to 63. Now, we check if the current node is a leaf node or not. Since node 3 has both left and right child, it is not a leaf node. So, we pass the left subtree of node 3. Root will now point to 2. Now, we update val as val into 10 plus 2. So, val will now be equal to 632. Again, we check if 2 is a leaf node or not. Since 2 does not have a left and a right child, it is a leaf node. So, we return val to the call stack. We continue for the right subtree of node 2. Since right subtree of node 2 is null, we pass null. Now, root will point to null. Since root is null, we return 0. Finally, we have 632 plus 0, which will be returned to the call stack. We continue for the right subtree of node 3. We pass node 5. So, root will now point to node 5. Also, since val was 63 during function state when 3 was called, so val will be equal to 63. Again, since root is not null, we update val as val into 10 plus 5. So, val will now be equal to 635. As 5 is a leaf node, we return val to the call stack. So, now we pass the right child of node 5, which is null. Since root is null, we return 0. So, the final value that will be returned will be 635 plus 0. Now we have 632 plus 635, which is equal to 1276, and that will be the value returned to node 6. We now move on to the right subtree of node 6. Val had value 6 when node 6 was passed, so val will now be equal to 6. We pass 6 right child, which is 5, to the call stack, so root will point to 5. Again, we check if root is null. Since it is not, we update val as val into 10 plus 5. So val will now be equal to 65. We check if 5 is a leaf node or not. Since it is not a leaf node, we call the left and right subtree of node 5. Since left child of 5 is null, we pass null. Now root will point to null. Since root is null, we return 0. So we have 0 plus tree path sum util 5 right, 65. Now we pass the right child of node 5, which is 4. So root will now point to 4. We check if root is null. Since it is not, we update val as val into 10 plus 4. So val will now be equal to 654. We check if 4 is a leaf node or not. As 4 does not have any child, it is a leaf node and we return val. So 654 will be returned. We have 654 which will be returned to tree path sum util 6 right. Finally, we have 1276 plus 654 that will be returned. Now, let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here, n are the number of nodes in the binary tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.